In chemistry, many of the numbers we use will be really, really small or really, really big. To make it a little bit easier to handle these numbers, we're going to use scientific notation. Scientific notation is just another way of writing a number when it's really small or really large. And it's written as n times 10 to the n power. So this n is the numerical value, and our little n is our exponent. And so if I want to take the number 459,000,000 and rewrite it in scientific notation, I'm going to rewrite it as 4.59 times 10 to the 8th. Because if I count, what I see is 1, 2, 3, 4, 5, 6, 7, 8. So we've counted over 8 decimal places. When we write a number in scientific notation, we always have one digit before the decimal place. All the remaining significant figures come after the decimal point. The 8 tells us how many places we'd have to move back in order to get back to our original number. Here we have a positive exponent. This is a very large number. If I have a small number, less than 1, I can do the same thing, but now I'm going to have a negative exponent. So here I can count over 1, 2, 3, 4, 5, 6. Again, I've gone over 6 decimal places, but now I'm going to the right, and so this, because it's a small number, so I have 10 to the minus 6. So every time I see a negative exponent, I know I'm dealing with a very small number. So how do we write a number in scientific notation? Well, we look at the number we're given. We see how many places we need to move it over. In this case, we'd have to move it over 3 decimal places. That's the same as writing 2.4 times 1,000. I could rewrite that as 2.4 times 10 times 10 times 10, because 10 times 10 times 10 equals 1,000. And so I can say 2.4 times 10 to the third. I still have my unit there because any number I have in chemistry is almost always going to have a unit associated with it. And so I have my coefficient, which is 2.4, my power, which is 3, and my unit, which in this case is meters. Now I look at another example for a small number, and I have 0.00086. Well, I can say this is the same as dividing by 10,000. So I'm dividing by 10 times 10 times 10 times 10, and that becomes 8.6 times 10 to the minus 4th grams. We still have one digit before the decimal place, and then all remaining significant digits afterwards. We can have more digits after the decimal place. In these two examples, they only happen to have 1. So why is this so helpful? Well, if I look at the number of atoms in a single grain of sand, I see that I've got quite a few. It's kind of a big number we're dealing with here. So instead, I'm going to write that number in scientific notation. And now, instead of having that really long number with all those zeros after it, now I have 1 times 10 to the 21st atoms in a grain of sand. Same number, same numerical value, much easier to enter into our calculator, much easier to manage when we're writing things down.